Okay, this tutorial is to show the solution to the normal distribution problem from the last week's test. Um, we know it's a normal distribution problem because it tells us right in the question. Also, we can see that this normal bell curve is going to give us a hint that it's a normal distribution. We're told that the number of t-shirts sold each week by a large department store follows a normal distribution with a mean of 300 and a standard deviation of 50. So important information to think about here is the units. So it helps you contextualize the problem. T-shirts sold each week. So that means there's a mean or an average amount of 300 t-shirts sold each week and a standard deviation of 50. Now the first question is going to ask you to sketch this. So even though this problem here says on the diagram below, I asked you to sketch it yourself. So here's what a sketch would look like. Here's part A. You can see that you've drawn a normal curve and that you've included the line in the middle with the mean and labeled it 300, and then your standard deviations are going up or down by 50 each time. Also important is to label the units, t-shirts per week, t-shirts sold per week. Okay, so that is the answer to A. Part B asks us to find the probability that the store sells fewer than 320 t-shirts in a particular week. And part 2 of this question says show this probability on your diagram. So I'm going to actually deal with the part 2 first, so we can take a look at the diagram and help us make some sense of part 1. If we go back to our diagram here, it says it asks us to find fewer than the probability that fewer than 320 were sold, and so that 320 would be about there. And you want to label that. Some of the students forgot to label that amount on the diagram, and that is an important piece. Now, also, just to be clear, because you're finding the area from here all the way on the left to that 320 mark. Now, you might be tempted to have thought, well, I'm going to go from 319 down because that's one fewer t-shirt per week. But really, since we're finding the area under the curve all the way up to 320, you want to be thinking about this problem as less than 320 all the way up to 320. So there's some space in between that curve, between 319 and 320. So we want to just be using the number 320 to solve this problem. So that's the diagram partly completed, but that's what we're going to be finding in the first part. Finding the probability that the store sells fewer than 320 t-shirts per week. So we're going to be finding this area in this curve, or under this curve. So probability of t-shirts sold per week being less than 320 can be found using second vars, and then you choose the normal CDF on your calculator, and it's going to ask you to input lower boundary, upper boundary, mean, which in this case is mu, the Greek letter mu, and standard deviation, which is the Greek letter sigma. Now this lower boundary, it's important to understand what's going on here. Essentially, we're taking this area from the 320 all the way down here. Now this goes on infinitely, and the standard deviation, the bell curve, never actually touches the horizontal axis. So there's always some area underneath this. So what we want to do is we want to think about this as for the lower boundary, we're finding a very small number because it goes on that way forever. Now a very small number would be -1 times 10 to the 99. power 99. That's -1 with 99 zeros after it. That's a very small number. That's a very cold temperature if you want to think about what the meaning of negative numbers is. So that would serve as our lower boundary just fine. And so we would use that amount for lower boundary. Our upper boundary is 320. And again, from the information given, 350 are our mean and standard deviation. So we would input that onto the calculator, and the output would be this value here. Now I had, remember that notation like this, 0.65542 ... is perfectly acceptable on the test. You do not have to put it to 3 significant figures if you show that ... If you want to, or if you're in the habit of it, then you can put 0.655, and that will be acceptable also. 0.66 is not acceptable, because that's only the 2 significant figures. So that is the answer to B1. Now we still haven't finished B2 because we're meant to be showing the probability on this diagram. So, well, so far we have successfully labeled the 320 and shaded it, but we also have to label the probability. So let's do that. 0.655. Now our answer for B2 is complete. Okay. For the last part of this video, I'm going to solve C, and then I will, in a second video, solve D through F. C asks us to find the probability the store sells fewer than 320 t-shirts. In each of 2 consecutive weeks. Now, this is like a compound probability problem in the context of normal distribution. So, first question we have to ask ourselves is, are these events independent or dependent? Well, dependent means like drawing cards from a deck where you would not replace the card. That's going to affect the second trial, the second drawing of a card. Is this dependent? No, it's not, because a store selling t-shirts in a week, in week 1, is not going to have an effect on the store selling of t-shirts in week 2. So they're independent events, so we can just multiply them together. So here we go. Since the probability of it happening in 1 week is 0.655. Then we can multiply 0.655 times 0.655. Probability of it happening in the first week times the probability of it happening in the second week. The result of that is this, 0.49577 ... and that again is sufficient accuracy as long as you put the ... on the test. Okay, I'm going to stop here, and I'm going to do problems D through F on the second video.